Alright, today's lesson is going to be on finding the area of regular polygons. Remember that regular polygons are polygons that are all the same side lengths and all the same angles. Okay, first theorem you're going to want to get down is a theorem for, or the formula for an equilateral triangle. And this just gives us another option. If we don't have the height, we can just use the side length. Let's go ahead and copy that formula down. S is equal to the side length of the triangle. Okay, in example 1, we'll look at a couple areas of triangle. And so let's start here. We have the area equals 1/4 s squared times the square root of 3. And we just go ahead and plug in what we know. We have 1/4 times 10 squared. So follow your order of operations. We square the 10 first, and then we can just multiply straight through. And we'll just leave it in radical form. So now we have 25 times the square root of 3. And we look at our units. Our units are in centimeters. So we have square centimeters because we are working with area. Okay, second example. Same formula. 1/4 times s squared. So we have the perimeter on this one is 6. So our side length would be 6 divided by 3, which is just 2. So we go ahead over here and we're going to plug that in. So we're going to put a 2 there. Squared times the square root of 3. So I have 1/4 times 4. And that gives me just the square root of 3. Again, we're in centimeters, so our units are centimeters, or square centimeters. So that is the triangle. And next we're going to start with other regular polygons, which could be anywhere from 4 sides up as high as you want to go. So go ahead and copy these definitions and this diagram and theorem down with the formula, and we'll work a couple examples. Alright, so here's kind of a step-by-step process generally in finding the area of a polygon. So you'll want to again jot these down in your notes and then follow along as we solve the next few examples. Go ahead and pause the video to write those down. Okay, and now finally an example. We have a regular octagon, so we are looking at an 8-sided figure, and it was inscribed in a circle. I took it out. We've got a radius of 4. Find the area of just the octagon. So I've already drawn the radius in. You can see that here from the center down to a vertex. Vertices are just the angles or the corners where the sides meet, so there's the vertices. And what we want to do next is draw in a triangle formed by the center and 2 vertices. So I'm going to start here at the center, and I just draw in another radius, forming a triangle. Now if I drew in all of these triangles, they'd all be the same size. So in order to find, we're on step 2 here, the central angle, I'm going to take 360 degrees, because that's all the way around, and I'm going to divide it by 8. Because that's the number of triangles we would form if we kept drawing in all the radius. So when I do that, I get 45 degrees. So that means this angle here, right here, would be 45 degrees. Okay, now we're going to go on to step 3. Step 3 says draw in the apothem. That is from the center straight down to the center at a right angle of a side. So we went midpoint, so we've of course formed a right triangle. Now the angle that's in here, in just this half of that triangle, is half of that central angle we just found. So I'm going to take that 45 degrees and I'm going to divide it in half. Okay, and we're going to use that as part of this right triangle to solve for the length of the apothem, because we need that to find our area. We also need our side length right here. And we're going to do that by finding half of this and then taking it times 2. Alright, so now we are on step 4. And the first thing we're going to find is the apothem. So we are going to go ahead and use cosine. So we're going to take the cosine of 22.5 equals, and this is adjacent, and it's our apothem, so A over 4, which is the hypotenuse. So go ahead and multiply both sides times 4, and I get 4 times the cosine of 22.5. Take that 4 over there, equals A. And when I do that, I get 3.7. And you can go ahead and just round, we'll just round to the nearest hundredth. If I can get the pen to write again, 3.70 equals A. Okay, so there's our apothem. We'll need that in just a little bit. Let's go ahead and we'll mark it. So we're going to come back to that. Okay, now we need our perimeter, so we need to find x. And I'm going to use the same 22.5, but since x is across from it, opposite, I'm going to use the sine. So sine of 22.5 equals opposite over hypotenuse. 4 times the sine of 22.5 is equal to 1.53. Okay, so then I'm going to take that. That is equal to x. Okay, so that's just one part of it. So if I take 2 times 1.53 times the number of sides that I have, that is going to equal the perimeter. So when I do that, I get 24.5. Okay, so that is the other part that we need. Okay, so now I'm gonna go ahead and, just so I have a little room to write, I'm gonna erase our first steps up here. And I'm going to calculate the area. So area is equal to 1/2 apothem times the perimeter. So I take 1/2 times 3.70 times 24.5. And that's going to equal approximately, and this is with a little bit of rounding, so we'll do an approximation, 45.25. And we don't have any units given to us, so it's square units. So we'll just use a U and not worry about what the units actually are. And there's our answer. So quite a few steps. It's not a simple problem, but you just have to very carefully go through and follow each step and find all the sides you need and plug into the formula. Let's look at another example. All right, we have a regular 12-gon with a side length of 1.2 and a radius of 2.3. So we're given a little bit different information this time. So I'm going to go down here and mark my diagram. So I have a side length of 1.2 and I have a radius of 2.3. So obviously we're not drawn to scale here. Let's see if we can find the center. Yikes, sorry about that. So there's our 2.3. Okay, so what we'll need to find is the apothem. We'll just blame the pen for why that's not straight. All right, so in order to find the apothem, it actually kind of is the pen. Okay, we have a right angle here, so I need to know, well, normally I would need to know what that angle is, but since I have two of the sides, because I know if the side length is 1.2, we'll just see if we can draw that better. If the side length is 1.2, then half the side is 0.6. That's a little bit better. Alright, so I know that that radius is 2.3, and I just need to find the apothem. I have a right triangle, so this time I don't need to use the trig function because I have two of the sides already. So I can just use the Pythagorean theorem. And let's see if we can do this. So I would say a squared plus 0.6 squared is equal to 2.3 squared. And if you go ahead and calculate that out, we get a squared is equal to 4.93. And a is equal to 2.22. Okay, we just took the square root in order to find that. Alright, so there's one of our measurements that we need, so we'll mark that we're going to come back to it. Now we need our perimeter. So remember, perimeter is just the length of one side, which is 1.2, times the number of sides. And in this case, I have 12 sides. So the perimeter is 14.4. Okay, so that is the other piece that we're going to come back to. And now we just need to use our formula for area. So we're going to take area equals 1/2 A times perimeter. So I have 1/2 times 2.22 times 14.4. And you just plug that into your calculator and multiply that through. You're going to get approximately, and you can follow along on your calculator to make sure you get the right answer too, 16 square centimeters. All right, one more example, because I don't think you can have too many of these. We have an area. We want to find the area of a regular n-gon with a side length of 6. And I've had the diagrams on all the others, so my hint to you now is that you don't actually have to sketch the entire shape. You can kind of just draw a sketch of, I always draw about 3 sides to get the idea that it's a shape that goes around. And then I just remember I have 6 sides and I mark what I need to know. So I have a side length of 6. And that is all I have right now, other than I know that I have 9 sides. So if I approximate where my center is, drawing the radius, drawing the apothem, I'm going to have to find that. I know that this side is 3 because I've cut a side in half. And I'm going to need to find the apothem. And since I only know one side, I'm back to having to use some trig. So I need to know what this angle is right here. Okay, so remember I do that by taking 360 and dividing it by the number of sides. So that's 40. And then I take that 40 degrees and I divide it in half. So I have a 20-degree angle right here that I'm working with. Now I need to find the apothem, and I know the side opposite the 20, and I need to find the adjacent. So I'm going to work with, if you remember your SOHCAHTOA, I'm going to work with tangent, because tangent of any angle equals opposite over adjacent. Okay, so our tangent of 20 degrees is equal to 3 over A, and A is equal to 3 over tangent 20. Okay, so when I take 3 divided by tangent 20, I get 8.24. Right, so there is our A value that we need, and we'll come back to that one. Now I need the perimeter. So perimeter is the side length times the number of sides, and that is 9, so we're at 54. And then we just plug into our formula. Area is equal to 1/2 times the apothem times the perimeter. Okay, when I multiply all of that out, okay, so when I multiply all of that out, I get approximately 222.5. Check the units again. We're in inches this time, so it is square inches. Alright, so last thing is, go ahead and give this problem a try on your own and bring the answer to class tomorrow.